Hello everyone, welcome to my channel. Today I'll explain my Python program that demonstrates two important graph traversal algorithms, BFS and DFS. These algos are widely used in CS for exploring graphs. A graph is a data structure that consists of nodes called vertices and edges that connect two nodes. Graphs are commonly used to represent real world networks such as social networks, road networks, and computer networks. In my program, I implemented both BFS and DFS in Python and tested them on three different scenarios. Firstly, I imported the DQ data structure from collection module. DQ stands for double-ended queue and it allows fast insertion and deletion of element from both ends. It is also useful for implementing queues which are needed for BFS algorithm. Now I'll explain the BFS function. The function takes two parameters, the graph and the starting node. Inside the function I create three variables. The first variable is a set called visited which stores all the nodes that have already been visited so that we do not visit them again. The second variable is a queue which initially contains the starting node. The third variable is a list called traversal which will store the order in which nodes are visited. Then a while loop runs as long as queue is not empty. Inside the loop, the first node is removed from queue using pop left. If that node has not been visited before, it is added to the visited set and also added to traversal list. After that, the algorithm checks all the neighbors of that node from graph. If a neighbor has not been visited yet, it is added to queue. This process continues until all reachable nodes are explored. Finally, the traversal list is returned, which shows the BFS visiting order. Next, I implemented the DFS function. This function also takes the graph and starting node as parameters, but it additionally uses op- optional parameters called visited and traversal. If they are not provided, the function initializes them as an empty set and an empty list. In DFS, the starting node is immediately marked as visited and added the traversal list. Then the algorithm looks at each neighbor of that node. If a neighbor has not been visited yet, the function calls itself recursively for that neighbor. This means the algorithm keeps going deeper into graph before returning back. This recursive process continues until all nodes are visited. Finally, the traversal list is returned, which shows the DFS visiting order. After implementing the two algos, I created three different graph scenarios to demonstrate how the algorithms work in real world situations. The first scenario represents a social network graph. In this graph, nodes represent people and edges represent friendship between them. For example, node A is connected to node B, C, and D. When the program runs BFS starting from node A, it visits node level by level such as A, then B, C, and D, and then their neighbors. In DFS, the traversal goes deeper first, for example, A to B to E before backtracking. The second scenario represents a city road network. In this case, nodes represent cities and edges represent roads connecting them. The BFS algorithm can be useful here for finding the shortest path between cities because it explores nodes level by level. The third and most important scenario represents a computer network. Nodes represent computer or routers and edges represent communication links between them. Graph traversal algorithms are important in networking for routing packets and discovering paths in network. In this program, after defining each graph, I printed the BFS traversal and DFS traversal starting from a specific node. This allows us to compare how both algos explore the same graph differently. To summarize, this Python program demonstrate how BFS and DFS work on different types of graphs. BFS uses as queue and explore nodes level by level, while DFS uses recursion and explore nodes deeply before backtracking. These algorithms are fundamental in computer science and widely used in applications such as network routing, pathfinding, AI, search problems, and social network analysis. Thank you very much. Take care. Allah Hafiz.